All right, welcome back. We're going to be going over vars, brackets, and braces. So we're going to set up our foundation to use bash at this point. Now, with that said, there are some assumptions built into this, like there are some bash commands that we're not necessarily going to go over like we have up to this point, where I'm calling out individual things on slides, telling you exactly what they are. Instead, what we're going to do is, as we need them, as we use them, I will call them out and tell you what they're doing. Okay, and the reason for that is because we only have so much time for the semester, and we need to be able to get through this content without taking 4 weeks to set up what we're trying to do with bash. So this is a pretty good compromise from where we stand here at Alfred State. So just keep that in mind as we're going through. If I use something like, I call it chmod, but change modification, uh, I will call it out and tell you what it's doing, or at least what I'm trying to do with it. Okay, so let's get into the presentation real quick, and then after that we will install a distro with a VM more than likely. We can also use a Windows sub system if you want to do that as well. That's not going to give you the ability to run a GUI environment, which we might need later on in the course, so that is up to you. So what is bash? Well, it stands for Born Again Shell. Okay, it's a CLI wrapper that gives access to system resources and its components. One thing I need to point out here, the difference between a scripting language and a programming language is that a scripting language is going to come with a significant set of limitations. One of which in bash is that you can only use integers. Okay, not the best thing in the world, especially if you're trying to do like a general programming language. It doesn't work out real well. A lot of scripting languages as well have what we call commands that allow us to do things quickly. The disadvantage of doing something like that is that we usually don't have very much control over what those things are doing. We might get an error code back, we might get results back. Another good example of this is if we use AWK for regular expressions, we're going to get the entire line back instead of the matching expression. So those are limitations that scripting languages usually have. Okay, so most bash scripts are short and straightforward, so they're there to accomplish a particular purpose. These scripting languages are not meant to be object-oriented. There are some things like functions built into them where you can reuse particular sets of code. However, it's not necessarily meant to create, well, you can't create a class, and you can't create objects like you would in object-oriented language. So if you find yourself where you need those controls and functionality, yeah, make sure you have more tools than just a hammer, because you don't necessarily want to make everything look like a nail. So you have other tools. You have Python and C++, both built in and both native in most distros. You can always install a different programming language as well. But if you want to keep it compatible across multiple machines, Python and C++ are your best answer for the most part, depending on the distro, of course. But for the most part, Python and C++ for your object-oriented programming languages. Jargon. Bash is white space sensitive, and what we mean by that is if you have a space character in the wrong spot, it very easily could not work. So a easy example of this is if you're trying to do testing with brackets, which we'll get to on this slide a little bit later, and you have no spaces, it's not going to work. And yeah, it's kind of annoying. White space sensitive languages are annoying. Even something like a YAML file is pretty annoying as well, just because of white space. But With that said, it does take away a lot of the typing that you have to do to get something to work. So, trade-offs, right? So, since we were talking about brackets before, let's go through that little section there. So, your round bits, right, are parentheses. A square is your bracket, and then your curlies are your braces. All right, so those are going to mean different things depending if you have one or two, and we'll get into that later on with expansions and substitutions. But just for now, this is the jargon that we're going to be talking about. Parentheses for the round ones, square for brackets, and then curly braces are braces. Okay. Environmental variables are saved on your system. So if you're using Bash, doesn't matter what system you're using it on, you're going to have a few environmental variables or a few variables that are pre-made for you. So home or tilde is your home directory of the current user. Okay, you're going to be using that quite a bit. PWD, current working directory, host name, self-explanatory. Language, also self-explanatory. All right, there are others as well, but those are the big ones. So let's move on to variables at the moment. Store information into a bucket. If you haven't taken programming 1 yet, and you're new to this and you're finding this on YouTube and you're not an Alfred State student, a variable stores information into what we call a bucket, but it's a named bucket. So if I want to store someone's name, like mine, if I'm going to put it in as first name, that first name is going to equate to the value of Justin. Okay, so instead of passing strings around, this is how you make your code scalable and modular. You just say, okay, whatever the first name is, whatever value that is, insert it into the database or something like Bash. It's going to be something along the lines of create this new user, first name of Justin, last name of Briggs, and then occupation is going to be something along the lines of professor or designer. Okay, this bucket is a place in memory. If you're familiar with other programming languages, this uses a pointer. All right, pointer is a memory address. Bash variables are untyped, and what we mean by that is there are no strings, there are no integers, there are no, we're not typing anything. It is untyped, okay? Moving on to setting variables, okay? So this is how you do it. var1 equals hello world. And this is what we meant on the other page as no spaces. You can't have a space in here. So if I had a space here and a space here just to make it a little bit more readable, this is not going to work. This will not set the variable. And this is what we meant by white space sensitive. This is the problem with white space sensitive things. It's very easy to get to a point where you have something like this and it looks fine and it's not going to work. Here are your pre-made variables. You're going to be using these quite a bit when you're doing your scripts. They are quite handy. All right. Again, like other lectures that we've done in this series so far, you don't necessarily have to memorize these. You'll memorize the ones that you use a lot. You're going to be using this a lot. Everything else you can look up. Just know that anything with a $sign in front of it is one, it's a variable, but two, likely there's a pre-made variable if it's something that you're going to use a lot. So $sign user, hostname, random, those are things you're going to use frequently. So yeah, just make sure that you know that it exists and that you're not necessarily recreating the wheel because it's probably already made for you. Okay, a single parenthesis runs commands inside of a sub shell is going to return 0 for no error or 1 for an error. So if we use the example here of echo hello world and then we echo the last variable that we have from this single parenthesis, the result is going to be 0 of no error, not necessarily the echo of hello world. So it is not advised, well, you can't. You can't do anything like a mathematical evaluation here and then expect the number to come back as something like 5. It's either going to be a 0 or a 1, a true or a false. Double parentheses, so this is going to perform math and no output. So by output in this case, it's going to be no error or no error. So it's not going to return 0 or 1, it's going to return a number. And like I said earlier, Bash only supports integers, so as long as it comes back as an integer, you're going to be okay. And it's going to echo 10 here if you use this example, which is right there. Okay, double parenthesis. $, single parentheses. So this is going to run a command inside of a subshell, and basically the only time you're going to be using something like this is if you need it inside of a string. So again, if we're going to use my name, my first name as an example, hello, my name is, I have it as who am I here, but if I put first name there, it's going to print first name, or it's going to echo first name in this case. All right. Okay, $, parenthesis, $, question mark. We'll run command inside of a subshell as well, but it's going to return a 1 or 0, so it's going to be 0 for it worked or 1 for error. Okay, I don't use this too often, but again, it's a tool that you might need in the future. $, double parentheses functions very much like double parentheses. Not much reason to use it over double parentheses. However, it is out there, it is around, people use it, so you need to know what it does. But essentially it does the exact same thing, except for there's a little bit more in terms of testing functionality. So occasionally you might need it, but not usually. Okay. Single bracket, and this will test for truth. Again, it's going to return 1 or 0. Okay, so this is a testing methodology. So in my example here, I have 1 equals 2, which is false. That's going to return as a 1. Okay. Double bracket, this is a test and return the result. This also supports a regular expression as well. So in that last example where we had 1 equals 2, it's going to return false. Single bracket used for expansion, okay? Used to create patterns. That's all you need to know about this. Used to create patterns. So if we have echo here, and there's H, and then we have our expansion bracket here, and then it's A, E, I, O, and U, and then with a P, it's going to result as HAP, HEP, HIP. I'm missing a comma in my PowerPoint, hop and hup. Okay. Same thing with if you have brother, sister, mother, and then that's going to echo brother, sister, mother on different lines because we're using echo here. All right. Okay, single brace, used for expansion as well, used inside of strings if you want to do that. And that's it for this slideshow. So what we're going to do now is make sure that we can install a Linux distro. So we're going to do this. We are going to open up VirtualBox. You can use whatever virtual software that you are most comfortable with. It is most certainly not going to matter for this course. Okay, so I'm going to create a new one. I'm going to call it scripting. Okay, instead of that, I'm going to come down to, well, I guess I can use Linux, but I want Ubuntu 64-bit. So there's that. I'm going to go up to 4 gigs here. I have plenty of space. You can do it at 1 gig of RAM. That will be fine. We're not going to do anything intensive. Okay, create virtual disk now. Okay, instead of 10 gigs, I'm going to give this 30 because it's going to make me feel a little bit better. Okay, we're going to create. Okay, now I need to come over here to settings. Come to system. I'm going to put hard disk up here. I'm going to put optical up here. I'm going to take off floppy for boot order. I'm going to give myself some more threads. I'll go up to 4. Okay. Video memory, enable 3D acceleration. Give myself some more video memory. Storage. Bang. We need to select a disk file. And I'm going to see which Ubuntu that I actually have. 18, 19, 20. Okay, so I'm going to use the 20 long-term support here. We're going to OK this. And now we're going to start. Now, if you did not have a Linux distro downloaded for the ISO, just go to any one that you're looking for. Obviously, if you want to follow along with me, a Debian distro. It's going to work out for you. So Ubuntu, Mint, those are going to be your big two. Yeah, just stick with one of those. Start. And just to be clear, Fedora is Red Hat. Kali Linux is Debian as well, but it's much closer to Debian than what Ubuntu is, and it's a little bit different as well. So that is up to you how you want to handle that. So we're going to install Ubuntu here. Okay, so we're going to wait for this option here to install Ubuntu. Here it is, install. Good. I'm going to install third party, that's fine. Erase disk and install Ubuntu, that is fine. We're on a virtual disk, so you don't really have to worry about it. Continue. Okay, my name, computer name, oh, let's go Maru, why not? Username. And this is one thing that you want to stay away from. You do not want login automatically, okay? This has caused problems for me in the past. It just depends on your hardware and how you're doing this. But this can get ugly really fast if it doesn't work. So requirement password at login. So this is going to take a few minutes to actually get to what you want. And if you didn't switch your bootable disk in VirtualBox or VMware, if you're using that, what's going to end up happening is that when this restarts, it's going to boot back into the install ISO, and that's going to be a problem. So make sure that you have the correct boot order on your virtual software. All right, so this is going to take a few minutes, and I'll see you guys after this is done installing. Okay, so we're at the point where we need to restart, and then we can boot into Ubuntu natively. So let's go ahead and do that. Okay, remove your installation medium. Now, we don't do that because we're on a virtual machine. That is fine. However, make sure your boot order is correct because it will boot back into that installation media if you don't have the boot order correct. Okay, so here we go. So there's my account. I'm going to log in with that password. Okay, So one of the first things I'm going to do is make sure that I can actually see what is going on. So display settings, I right click to get there, by the way. Display settings, a landscape, I'm going to make this bigger. Too big, well maybe not, let's try this one. Okay. Scale 200. Keep changes. Come on now. It is upset about that. Okay. Down here, here. Okay, I right clicked on this again. Okay, yeah, something's going on with that. So, hey, again, the awesomeness of Linux at times. What is this? Sure, we'll install those updates. Why not? Here we go. All right, well, let's open this up. Nope, wrong one. We're going to go to System Monitor. We're going to go to Processes, which we already have. There should be a status on one of these. Maybe not. Right click, status. Here we go, sleeping. Let's organize these. Running. Everything else is sleeping. Interesting. Shell, System Monitor, Update Manager. I don't know what this is. Anywho. Okay, so this is not working at the moment, so I'm going to go ahead and restart. Like so. Interesting. Okay, let's pull up a VirtualBox, and we're going to force close this. Close, power off. Okay, and now we're going to restart this. So this is part of the reason why Linux desktop hasn't taken off. Simple things can go wrong. Things that you would think were solved by now have not been. So here's this. Okay, back on here, we're going to skip that. We're going to skip live patch. We can send information to that. We do not need location services, and we will install software here in a second. So at this point, everything seems to be working now. I'm not sure why it was being fussy before. However, I think I can make this a little bit bigger. So display settings. This is full screen, so keep changes. Okay, we're going to have to deal with a little, that's kind of annoying. Yeah, let's do this one. Okay, yeah, we're going to have to call that good enough. Okay, so at this point, I want to install Visual Code. That's the only thing that we're going to end up installing. However, uh, we're going to go to terminal to do that. So we need a couple things first. First, we need snap. So sudo apt install snap. Oh, no extra p. This is going to be mad. I'm pretty sure I need snapd though. So the D in Linux stands for daemon. So a few of you probably noticed that I used snapd instead of just snap. The D stands for daemon, which is essentially just a piece of software that runs in the background that does services for you. Okay, so some things are going to be the name of the thing with a D at the end of it. Okay, so snapd was one of them. I'm going to refer to it as snap from now on because that's what it's called. Okay, so at this point, now that we have snap installed, we can use it to install Visual Code. So sudo snap install code and classic. So we need that classic tag so we can actually install Visual Code, mostly because that is the type of snap package that Visual Code has put into it. Most others, you don't need that classic flag. So for the time being, just know that you need classic for Visual Code. All right. And since we're on the topic of using snap, if you don't know what the terminal line command is called for a particular piece of software, you can go to snap software. Okay, Linux snap. There you go. And then if we search for Visual Code, okay, it's going to come up as code. And then if we come over here to the install button, we have sudo snap install code classic. So if you needed a different one, let's try. And this is the only thing we don't like about the Snapcraft website is that you have to go back to the home page to search for something. Let's do Node.js. Didn't come up. Let's try taking away that space. Node.js, Kali Linux. We do not have Kali Linux. There's Node. There it is. Okay, install. This also has a classic to it. Okay, so let's try to get one that doesn't have classic to it. So let's try OBS. OBS Studio. Install. And this one doesn't have a classic flag to it. So this is how you find commands if you need them. So if you're making a script where you want to create a script that always installs the software that you need, then this is a good way of getting the command that you need for that script. So let's go ahead and exit out of that. Make this full screen, bigger. Okay, so we're doing better here. First thing I want to do is get a feel for the file system that is around here. So, and go over a few commands of getting around the file system. So the first thing that I'm going to do, and it's as easy as it's going to get, is I'm going to do an S, which stands for list, and this is in my home directory. So desktop, documents, downloads, music, pictures, public, templates, and videos. Okay, so this default me to my home directory. So if I go up a directory, so to do that, I need to cd, which stands for change directory, // goes up a home, or up a directory, not a home directory, but just a directory. So if we go up to a directory, notice that we are in the home folder now. So if I list this, I get Briggs JA. All right. If I do that again, I go up another directory. Notice that we have / here. Now we're in the root directory. So if I list this, we get a bunch more options. So again, this is how you start to get around. Now, let's say that I want to get into, let's say, etc. So etc is in our root directory here. So cd, come on, do what I want, etc. We are in etc. We're going to list, and we have a bunch of options here, and there's a bunch of things in this etc folder. Now, let's say I want to get back to my home directory. Let's say I've gotten lost in the weeds, and I know how to get to where I want to go as long as I can get back to the home directory. So cd, and this is where we can use tilde. List. We're back in our home directory. All right. Same thing with getting to the root directory. We can do cd / and now we're back to the home directory. And now let's say that I want to, oh, I think it's users, right? Nope, it's home. So cd home Briggs JA pictures. One thing to note about Linux is that your file pathing is case sensitive. Unlike Windows, if I did this, it's not going to work. If I come up here, now it did, and the only thing I changed was the case of that P. So that's another thing that you need to keep aware of. But my original train of thought here was that if I'm in the pictures folder and I'm in a directory and I'm trying to get somewhere else, and I don't necessarily want to go cd up a directory, cd up a directory, cd up a directory, you have a few options here. The one I'm going to use is cd. We're going to start at the root directory, etc. And that is going to get us back to that etc folder that we had that is up here. So there's that. Enter. And notice that we're in the etc folder. We're going to list. We're back there. Now, let's say for some reason we don't want to use tilde. We got / here for the root directory. We have home. We have Briggs JA. Okay, and that's going to get us into our home directory. All right. So this would be useful for if you had multiple users on a single computer and you, as the current user, was not the one that you wanted to get to. That's how you do that. The other way that you could do that is do change directory, tilde. Actually, let's test that real quick. We're going to go into pictures. Okay, so we're going to change directory, tilde, up a directory, and then see if that's going to work. No such file or directory. Let's add that / in there. And now we're up in that directory. So if we had a different picture here, I'm going to make a directory here. So mkdir is make directory. And I'm going to call this test user. Nope, permission denied. Sudo. Okay, test user. I'm going to list. And now that I have that test user folder here, I can go back into Briggs JA, pictures. Okay, and now if I need to get to that other test user directory, I can do a cd tilde slash up a directory test user, and I'm in that test user folder now. So hopefully you understand relative file pathing up to this point. It's going to take a little bit of practice, but for the most part, if you're in my class, go ahead and ask the question if you need to, but that is a brief overview of how to get around in the file system. So with that said, this video has gone on for quite some time. So let's go ahead and get out of here. Let's get back into my directory. And then I want to I want to make a new directory, and I'm going to call it scripts. Okay, let's make sure it's in there. And right there is scripts right here. Okay, I'm going to change into that directory that I just made, scripts, and I'm going to use a command called touch now. Touch hello world .sh, which is, you can do this without the sh, but this helps other developers know that this is intended to be a script. Touch, I'm going to list, there is our hello world script. So I am going to, at this point, to avoid problems here in the future, chmod plus x, which is executable, hello world .sh. So this just made our script executable. So if I list again, that hello world just became green. Okay, this signifies that this is executable now. So I'm actually going to use nano here. Actually, I'm going to use sudo nano to avoid permission problems. Sudo nano hello world .sh. I'm inside of that file now, and I can edit it as need be. So at the top of every bash file, bin bash, you need to have this. And what this is going to do is tell the script what type of scripting language you're going to use. Now, with that said, I'm going to echo a string of hello world. Okay. I'm going to save this by exiting Control X, which is down here at the bottom here, Control X. It's going to ask me if I want to save that buffer, and it's going to be a yes, so I'm going to press Y. File name to write, hello world.sh. I am good with that. Enter. And now that we have that, so what I'm going to do is redirect here, hello world. That should have totally worked. Cancel. Can I do this? Print hello world. Oh, it's cat. It's cat. I forget commands too. Cat hello world .sh. Okay, so there's the content of our file from hello world. So now we're going to run this file just to make sure that it actually works. So we're going to do a // hello world.sh. Hello world. So we just ran that file and it echoed hello world. So this is kind of where I wanted to stop, just to make sure that everything is up and running. You had an opportunity to get through the file system, have an opportunity to use the terminal, and that we actually got a script running. Okay, so with that said, that's going to do it for this video, and I'll see you in the next one.